All right, people, we're going to introduce the concept of limiting reactants with something that is related before we put the numbers in tomorrow. So limiting reactants is really talking about the fact that when we do chemical reactions, very rarely do we have exactly the right amount of both substances. That's kind of like one of those naive things to think that you could have exactly the right amount. Even if you carefully measure, there's usually some inconsistencies. So if you do not have exactly the right amount of reactants, sometimes you have to figure out which one is the limiting reactant. And the limiting reactant is the one that limits the amount of products that we can make. So let's talk about it with sandwiches. We're going to produce a salami sandwich. And only in this class would we put one piece of salami on a sandwich, huh? But that's what we're going to do. So we're going to relate this to a chemical equation. We're going to take 2 pieces of bread and 1 piece of salami, put them together, and we will get a sandwich. So 2 pieces of bread, 1 piece of salami make 1 sandwich. This is going to be like our mole ratios that we learned about. So if you remember, mole ratios are important. They come from the balanced chemical equation, and they're going to be used in our limiting reactants problems, and you're going to get to really see what a BCA chart is for. So bread and salami react in a 2-to-1 ratio to produce sandwiches. So what would you get if you had 4 pieces of bread and 2 pieces of salami? We still got the right ratio. So we're all good. We're going to produce 2 sandwiches. But what if we don't have exactly the right ratio, which happens all the time? So we still have to maintain our ratio. We're going to have 2 pieces of bread and 1 piece of salami for each sandwich. So in 6 pieces of bread, if you only have 2 pieces of salami, you can only form 2 sandwiches, and then you have what's called leftover. So salami is the limiting reactant. It limits the amount of sandwiches we can make, and bread is the reactant in excess, and it will have leftovers. So we've talked about reactants in excess, meaning that we have plenty of them. Now we're going to have to be in a position where we calculate the excess. Why? Because the ratio still has to be maintained regardless of how much you have. So if we have all of this bread, the ability to make sandwiches is going to stop once we run out of salami. So our sandwich making days are over once we run out of salami in this situation. And our bread is going to be called what's called leftovers. The ratio is maintained. Like in the real world, we just put all the salami in one sandwich and make a good sandwich. But in our analogy, we have more salami now, but we still have to maintain the ratio. So we can still only make 2 sandwiches from 4 pieces of bread. So in this case, bread is the limiting reactant, and the salami will be leftover. Salami is in excess. Take a look at this reaction, guys. What do you think this reaction could be? What are we producing here, you think? Water. Very good. So in order to produce 2 molecules of water, we have to have 2 molecules of hydrogen and 1 molecule of oxygen gas. These molecules have to come in contact with each other in the right orientation with the right amount of energy. So 3 things have to happen. These molecules have to collide. They have to collide with enough energy, and they have to collide in the right orientation. Like such. And that ratio is always going to be maintained. 2 molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water. And this happens all the time. Molecules of hydrogen and molecules of oxygen hang out together all the time without reacting. They have to have the right amount of energy to react with each other. Does anybody know what the amount of energy needed to cause a reaction to begin is called? That's called activation energy. So you've got oxygen around you, all around you. And you've got combustible materials all around you. Even the plastic in those bottles on the lab tables, that's a hydrocarbon, just like gasoline. But the oxygen and the plastic will sit next to each other for billions and billions of years, unless you add activation energy. Do you think I could light that plastic water bottle on fire? Yeah. I just have to add the activation energy. So what do you guys think? Why don't they just take all this extra plastic we got laying around and burn it? Yeah, that's nasty stuff, right? The other thing is, does anybody remember what the products when you burn a hydrocarbon? So the ratio is always maintained. Let's look at this situation. If I have 7 molecules of hydrogen and 1 molecule of oxygen, what would happen? It does not turn into some crazy substance. The reaction ratio is going to be maintained. So we're going to produce our water molecules, and then the reaction's going to stop. Only 2 of the molecules can react, and the other molecules will remain unreacted. So the reaction stops once you run out of the limiting reactant, and the excess will be left over unreacted afterwards.